rolling 2 dice. What is the probability of rolling a 5 or 11? All right, there we go. Kind of set up as 2 dice, and we're going to talk about what is the probability of rolling a 5 or 11. You know, that can be interpreted 2 different ways, and we will get 2 different answers. So I wanted to open that up to you. This is kind of an open question, and we're going to look at it first as if I should have put, or maybe I shouldn't, I don't know. I wanted to leave it open so you would think about it a little bit here, folks. But does that mean a sum of 5 or a sum of 11? Or do we see a 5 showing on the dice, the thing ending up? So usually when we throw a dice, we're looking for one of those numbers between 1 through 6 on each of them. But obviously 11 doesn't appear on a 6-sided dice. The only way you get 11 is by adding it. So there's a little bit of kind of a question mark there. And again, if that was on a test question written like it was there, I'd accept both answers, okay? So let's see what it is. First of all, let's talk about it being the probability of. And notice what I used here. One of our callers yesterday sent me a question that says, what is the P of 1? She was rolling 1 die, all right? And there are 6 options. And she says, what's the probability of 1? And that's what that meant, P of 1. And it simply means P is going to stand for our probability function here, all right? So I'm going to go a little deeper here. I'm going to say, let's say a sum of 5 or a sum of 11, all right? So we're looking for 2 possibilities here. Now, what I want to do here, I want to go, first of all, we got to know how many outcomes there are. How many outcomes there are. So let's say I've got a red die and a blue die, all right? I've got red and blue right here, okay? So possibility is getting 5. Well, let's see. The red die could come up with a 1. It could come up with a 4. It could come up with a 2. It could come up with a 3. And in the same time, my blue little creature here, I hope these are coming through colorfully, could be a 4. Oh, that looks better. And we got a 1. We've got a 3 and a 2. So in other words, there are 4 options right there. 4 ways that we can add up to get 5. All right. Now, how do we get 7? Well, we don't want to get 7 here, do we? We want to get 11. How do we get 11? It rhymes with 7. How about it? Let's see. That means we would be using 5 and possibly a 6, because the only way we can get 11 is by adding 6 and 5. But it could come in kind of a red-blue manner, all right? So first die, second die. So there's 6 options here. So I have 6 successes. I have 6 successes for this situation. The question is, how many outcomes are there? All right. Yesterday we talked about it with 1 die. We have 6 outcomes. With 2 die, we multiply another 6 into there, because for example, let's say I get 1 on the first toss. All right. I've got 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. There's 6 more for each of these. So we're going to multiply, and we're going to get 36 total outcomes. And, you know, some people say, well, can you draw all those out? Not today, all right, but we could create those. But we could get ordered pairs all the way from 1, 1 all the way up to 6, 6. And there would be 36 of them, all right, 36 of them individually. So what's the probability in this approach? It's going to be 6 successes out of 36. Reduce that down, comes out pretty nice. We get 1 out of 6, 1/6. Now you say, Ernie, you said, what if we interpret it another way? All right. Let's suppose I did another one. And folks, can y'all take me off just a second there? Yeah, let me move over here to the other option. Let's suppose we have a situation where I say, what's the probability of showing a 5 or 11? All right. Now, obviously, I can't show an 11. All right. There's not an 11 on a 1 die, all right? So there's not going to be 11 showing up. But if I looked at this as another situation, remember I said rolling a 5 or 11, I really left it kind of open for you. So let's suppose the upper face is showing a 5. There are 6 ways that could happen on the red die. So we have 6, 5, 4, 3, 2, 1. And they could join up with a 5 all the way down the line there, what I'm trying to show you here. So 1, 2, 3, 4, 5, and there's 6 right there. But then I could also come along here. Watch this, this is going to be fun. I could also say, well, let's let this guy be, the red die be the 5. And then we'd have 5 and 6 for the blue. That's a different one, isn't it? We'd have, how about 5 and 4? I think I'm going to run it in my face here in just a minute. 5 and 3. How about it? Let's make that one blue so we can keep it straight. 5 and 2. And then we got the 5 and the, go red and blue. Whew, that gets hard keeping coordinated, color coordinated. That's a good word there. But look what we've got here. We've got 6 going this way. We have 6 going this way. But you know what? We only have 11 actually ordered pairs because this is a repeater. The 5, 5 is a repeater. So to show a 5, there are 11 options there. Ironically, the or 11, that doesn't have anything to do with it, all right, folks? Out of 36. That's your possibility of showing a 5. The 0, the 11, there's no way it can be shown, so that would be 0 over 36 if we're looking at a face, okay? So in both cases there, 2 different answers, and I would accept it if you showed it out how to do there, all right?
For more math help, visit TNLearn.org.